Yeah, I'm trying to bind.
I'm trying to bind.
I'm trying to bind just everywhere, right? Let's call this hand.
Distinction.
Distinction. Yeah, so I'm trying to bind just everywhere, man.
I'm trying to bind everywhere. I'm trying to bind to everywhere.
Everywhere.
Trying to bind
Exactly.
everywhere.
Thanks. How you doing, man? So we have a question right here. They say if a current of 2.4 ampere is flowing in a cylindrical wire with a diameter. So we have a diameter, okay? But we know whenever we deal with a cross-section area, we don't need diameter. We need what? Radius. So we're going to change that one to radius. And also you have to change this millimeter to meter. Now let's say what is the average current density in this wire? Average current density in this wire. So this is one of the easy questions. So how do we solve this? Okay. So average current density we represent by using this letter here. Average current density, or capital or small letter, equal to current flowing over that area with the current flow, mean cross section area. So we see the given us here, the current flowing equal 2.4 ampere. Oh, so this current is given. Oh yes. Now how are we going to get cross section area? Cross section area is very, very easy. So we say cross section area. Let's break down the cross section area first. So I'm going to come here, cross section area equal to pi radius square. You know what I'm saying? Pi radius or square. But do you have a radius? No, you don't have a radius. But we have here, they say diameter equal to that one. Oh, so what is if somebody give me diameter means if I take the diameter, look, if this is cycle here, all of this is diameter. Okay, so what radius? Radius meaning take a diameter divided by 2. Oh, so here I'm going to say my cross section area equal to pi. What is my R? Is gonna, instead of say d, they give me d, right? So in the position of this R here, I'm gonna say d over 2, and then what I'm gonna do, I'm gonna square, because to get radius, take your diameter divided by 2, and then what we do, we square. Now let's go. This is easy. So what is my diameter? So I'll say this. Let me say pi. We'll get into cross section area now. So my diameter equal 2. So I'm gonna say 2. But remember, this has to be changed in meter. So if you want to change in meter, okay, the diameter is 2, but whatever diameter you must divide by 2. But remember, this is millimeter. So if you want to change to meter, you must multiply by 10 power negative 3. You know what I'm saying? But outside we have a 2. You can even do here side, like you say, oh, you know what? I don't want to do right there. I want to do it aside. Okay. So if you want to do it aside, I'm gonna say, okay, let's do it aside, and then let's get to our D. But I think it's very clear here. Means we take our pi, diameter is 2, and then we divide by 2, and then we know to change. Okay, let's just do here our radius, and then we just do it all separate. Radius equal diameter over 2. What is the diameter? The diameter is given is 2 meter, so it's going to be 2.0. But to change to meter means I have to multiply by 10 power negative 3. You know what I'm saying? So this is diameter. We have to divide by 2. This and this going to be equal to 1 times 10 power negative 3. Oh, so I'm going to say my cross section area equal to, okay, so pi 3.14 times by 1 times 10 power. Look, this is going to be 1 square equal to 1. Or let's write 1 times, because this is 1, let's put a bracket here, 1 times 10 power negative 3, but all this stuff, it has to be square. So our cross section area, okay, what is the cross section area? Our cross section, if you put in the calculator, this is going to give us 3.14 times 10 power negative 6. Oh, but it's going to be meter square. So now when I look for the cross section area, we look for what is the average current density. Oh, so average current density. Okay, so let's get it. So it's going to be J equal to the current density, or whichever letter you're going to represent, equal to current flow. We got our current flow equal to 2.4. Oh, okay, plug it in then. Oh, so current flow equal to 2.4. Oh yes, come here, plug in the formula 2.4, and then we over area, cross section area we got, which equal to 3, which is this one, 3.14, and then we multiply by 10 power negative 3. You know what I'm saying? Now this gonna give us, if you plug in the calculator, it's gonna give you, okay, 7, 6, 4, 3, 3, 1.2 2102. You know what I'm saying? And remember, it's a cross section area, so it's meter square, so it's going to be meter square, and this is ampere. Okay? But if you want to change to scientific, look, it's very easy. Just in case sometimes they give you this answer in scientific notation. So if they give me scientific notation, I'll say let's change scientific notation. Is easy. So what I'll do, I'll just go back, because scientific you must go to the first number. Look, 1 step, 2 step, 3 step, 4 step, 5. Oh, you know what I'm saying? How many step? 5 step. Okay, so you come and you put the decimal here, but when you go to the left, you put your, it's 5, right? So if it's 5, say 10 power 5, and this can be 7.64. You know what I'm saying? And the unit is area per meter, ampere per meter square area. You know what I'm saying? My apology. Oh, so this is what is. This is what they ask us. What is the average current density? Our current average current density equals 7.64 equal to average current density equal to 7.64 times 10 power 5 ampere over meter square. It's just a waste of time. You do this question, it is easy like that, man. Thanks a lot. You know what I'm saying? Look, man, I believe in learning from how to do things. If first time, make sure you subscribe, and you know, you can just go and do donation to our Patreon page. I have a Patreon, I have a GoFundMe. You know what I'm saying? I have all the means of donation, because to make this project going, you know, any type of donation, the little that you think is too small for you, it could make a lot of change. And thanks a lot for all your time. You know, subscribe, don't forget, share this video, circulate to a lot of people, you know, because the meaning of this project, this program, is to help as many as we can. Okay, it's not only for one patient or two, because you might think it's not helpful for you, but for somebody next out there, it could be very, very helpful. So thanks a lot, man. And you know, any donation that you did to me, it means so much. I appreciate it, man. It means a lot. Go to our Patreon page, go to our GoFundMe, because we need to have a lot of things. We need to put them together, like camera, you know, and a lot of equipment, so that we can improve on, you know, a lot of angle, a lot of aspects of these projects. You know, thanks a lot, man. I appreciate and I love you. Peace, man. Bye. You know, this is one of my students of knowledge. You know, she wanted to introduce herself. What's your name? Could you please introduce yourself?
My name is Kali. I
Yeah.
went to Southend Primary School.
Yeah, China Wabantu. China Wabantu is everywhere, right? So this is my other student. His name, what's your name? Matthew, yeah, he's grade 11, man. So his aim is to score distinction, right? So you promise I want you to score distinction this time. And what's your name?
Joshua.
Joshua, how much you promise me to score this time?
Distinction.
Distinction. Yeah, so China Wabantu is everywhere, man.
China Wabantu. Everywhere. China Wabantu everywhere.
Everywhere.
China Wabantu
Exactly.
everywhere.
Thanks a lot, man. Appreciate it. Thanks so much. If you had to give advice, which advice would you give to the people or to the students?
Trust Amish.
Why would they trust me?
No, because it's really good. They actually has helped a lot. I redid first year for maths. It was my own fault, but also I didn't know a lot of the work. And Amish said lots of hard questions, and it's demotivating sometimes to do the harder stuff. You like just want to get done, but it's the hard stuff that makes you realize the easy stuff is easy.
Oh dances.